days.
Did you hear about the first ever California?
Okay, so now that we've started talking about proportions and ratios, we're going to talk about the properties of proportions. Again, I anticipate that you've seen this already, so that's a good thing. And so that we're going to pick up right where we left off. So we're talking about means and extremes. Every single proportion has means and extremes. So if you had to take a guess, which two terms were the extremes, which two were would be the means, and what do you think? Yeah.
Never mind.
Never mind. Okay. Yeah. What do you think?
Well, okay. So.
Okay.
I've never heard the word extreme be used before in math. Just thought I'd point that out.
Okay. What if I rewrote it like this? Does this help you? If you had to take a guess, which one do you think would be the extremes?
Oh, W and Z.
There you go. Okay, good. So W and Z.
Why does that make it?
Those are your extremes, right? Therefore, these two are your means. The reason is because the way that we solve these proportions, okay? Because one of them is called the means extreme property, but you probably have heard of it just called cross product, right? When you multiply in WZ and you multiply X and Y, what are you multiplying when you multiply? When you do cross product, what are you multiplying here?
WZ equals Y.
Equals YX, right? So you are cross product with the means and cross product with the extremes. That's why that's the reason why they call it. Do you guys still have a question? Okay. The next idea that we're talking about is the properties of proportions. Now you've seen most of these already, and most of them come naturally to you, but I'm going to throw in maybe one that's a little bit different, okay? So first of all, we could say if W over X is equal to Y over Z, then we could use that means extremes cross product saying, say that, then WZ must equal XY. The book calls that the means extreme property. You've probably seen it before as nothing more than the cross product property. Does that make sense to you guys? Hello? Yeah, that's the first one, okay? So that's the first one. I'm putting a little box over here for us, okay? The second one is, let's say I have if, how about W over X is equal to Y over Z. Then we can say that W plus X over X is going to be the same as Y plus Z over Z. Have you guys seen this one before? Okay, so you can add on that denominator, the respective denominator to each term on either side. So as an example of this one, so I'll do an example for you over here to represent this. Let's say we have 4 over 7 in proportion to 12 over 21, right? 4 over 7 is equal ratio to 12 over 21. Is that true? Multiply top and bottom by what? By 3. Good. Okay, now, so is it still true then if we did this? 4 plus 7 over 7. Is that the same thing as 12 plus 21 over 7? Now remember, our ratio was 4 to 7, right? Because this is still 4 to 7. So 4 and 7, how much is that? No, this original one, right? Oh, thank you. This one right here. Yeah. So what do we get? 4 plus 7 over 7, what do we get? 11 over 7. Same thing. What do we get? 33 over 21.
Oh, I see.
I don't get. Oh, you multiply by 3.
Yeah. Are these still in? Oh, I hate when that happens. I don't know what that. Oh, go away. Are these still in equal proportion? Yes, they are. Right?
That's cool.
They still are. 7 over or 11 over 7, same thing as 33 over 21. Okay. Does that make sense? Okay. Now, could I have done this for like the third property here? So could I have done, say, if I have, let's say I've got W over X equals Y over Z, then is it the same thing to say X over W equals Z over Y? Or is that the same thing?
No.
Yeah, it is. It's a property of proportions that we don't ever really use. See?
You said that 2 to 3 is not 3 to 2, so switching it.
Yeah, but notice I'm switching both sides of it, right? So try 2 to 1 is the same thing as 4 to 2. Is that true? Okay. Boys up front. You guys agree? 2 over 1 is the same thing as 4 to 2? Okay, now, is that the same thing? Do I have still an equal statement here?
They're still
No,
equal,
you
but
don't.
they're not the same thing.
Well, sure. I'm not saying they're compared to the first one. All I'm saying is that this statement is still true.
So I'm not compared to the first one.
Not compared to the first one. I'm
Okay,
just saying,
yeah.
but compared to each other. Do I still have equal proportions?
And does that like that plus like the
Okay, this is the fourth one that we've done? Yeah. So the fourth property of proportions that we probably don't ever recognize that we deal with. So A over B equals C over D equals E. So I have a bunch of equal ratios lined up in proportions, right? Yep. If these are all lined up, then it doesn't matter how many we have. We can actually say this. We could say A plus C plus E plus G plus whatever all over B plus D plus F plus H plus whatever, all that stuff. It's a very interesting one, and we don't ever really talk about this one, so definitely want to point out to you. So let me give you an example of this one right here. Let's say we all agree that 2 over 3 is the same thing as 6 over 9. It's the same thing as 10 over 15. Is this all true so far? You guys agree with this?
Yes.
Yeah, these are all equal ratios here, right? Set together, so now I've got about 3 proportions in there. All right, so 2/3 equals 6/9 equals 10 over 15. Well, the property says this. If I take 2 plus 6 plus 10 all over 3 plus 9 plus 15, what do I get on the top? I get 18 over what? 27. Is that still in a 2 to 3 ratio? Yeah, it is. Still in the 2/3 ratio. So that's that property in action there, right? Huh?